Hello and welcome. Today, we'll delve into the concept of float and how it is related to critical path. Float, also known as slack or buffer, is the maximum amount of time an activity can be delayed without affecting the total project duration. Float can be divided into three main categories. Total float, the maximum time an activity can be delayed without impacting the total project duration. On the critical path, this is always zero. Free float, the time an activity can be delayed without delaying any succeeding activities. Free float is always less than or equal to total float. Project float, the amount of time the entire project can be delayed without affecting the final completion date. Float can be zero, positive, or negative. Zero float means the activity cannot be delayed, as it's on the critical path. Positive float means the activity can be delayed without affecting the project timeline. Negative float is a red flag, indicating that the project is already delayed, which must be avoided as it creates problems before the project even starts. In the critical path method, a logic diagram known as an activity on node diagram is used. Here, nodes represent each activity, and arrows indicate the relationships between them. The critical path is a sequence of tasks that extends from the project's start to its finish without any float. To determine the float, we use two methods: forward pass and backward pass. Forward pass calculates the early start and early finish values, showing how soon tasks can begin and finish. Early finish equals early start plus duration. Backward pass calculates the late start and late finish values by working backward from the project's end. Late start equals late finish minus duration. Float calculations help prioritize tasks and manage delays. Here's how we calculate it. Total float is calculated as total float equals late start minus early start, or late finish minus early finish. Free float is calculated as free float equals lowest early start of successors minus early finish. This helps distinguish between critical tasks that must stay on schedule and non-critical tasks that can be delayed. In complex projects, there can be multiple critical paths, which makes it harder to prioritize and optimize resources. Strategic allocation of resources to critical tasks and efficient resource management can help minimize float and ensure the project stays on track. Understanding float and its relationship with the critical path is crucial for managing project schedules effectively. Whether it's zero, positive, or negative, float helps you plan around delays, prioritize tasks, and allocate resources efficiently to avoid disruptions. In traditional, or predictive, project management, float plays a key role in scheduling. However, in Agile, flexibility is managed differently, using iterative cycles and backlog prioritization. Float is less prominent in Agile, but the concept of flexibility remains essential. Let's see a simple example of activities on critical path and calculate the early start, early finish in the forward pass and late start, late finish in the backward pass and calculate float. Thanks for watching. If you found this video helpful, give it a thumbs up and subscribe for more project management insights. Got any questions about float or the critical path? Drop them in the comments below.